Hi, and welcome to the independent practice for lesson 14.3, which is about comparing rational numbers. So we're going to first compare these rational numbers, and I'm going to tell you right now, this is the order. The square root of 8 over 2, well, let me show you real quick. Square root of 8, boy, that's going to be like 2.9. So this is 2, oops, 2.9 over 2. Ooh, that's like 1.5. It's about 1.5, about 1.5. And then we have 2, and then the square root of 7. Well, that's in between 2 and 3. Let's call it 2.5, about, and that would mean that's our order from least to greatest. Next, we have square root of 220. Oh man, the square root of 220. I'm thinking of the closest square root to that. 10 times 10. 14 times 14 is 196. 15 times 15 so 15 squared is 225. So let's call this 14.9. And then the square root of 10, I'm sorry, negative 10 is negative 10. That's going to be pretty easy. The square root of 100, that is 10. And then we have 11.5. So the smallest is negative 10. That's the smallest, negative 10. And then we have 10. So this one would be the next one. And then 11.5 and then 14.9. Those are the four numbers. And let's see what we got. Negative 10 and then square root of 100, which was 10. Yeah, okay, there's there. And then 11.5, I said, was the next one. And 200 square root of 220 was 14.9. Let's see this one. Your sister is considering two different shapes for her garden. One is a square with side lengths of 3.5 meters, and the other is a circle with a diameter of 4 meters. Find the area of the square. Find the area of the circle. Compare the answers of parts A and B. Which garden would give your sister the most space for plants? Space to plant. So side lengths. So this would be the area of this would be 3.5 squared, which I believe is 12.25. And the area of the circle with a diameter of 4, that means a radius of 2, so it'd be 3.14 times 2 squared, which is times 4, which is 12.56. And so we should have 12.25 and 4 times pi, which is about 12.6 or 12.56. Okay, so which one gives you more? The circle does, right? Because 12.6 is a larger number. And we have this. The circle because it has a larger area. That sounds pretty obvious. Okay, so Winnie measured the length of her father's ranch 4 times and got 4 different distances. Her measures are shown on the table. Okay, so we need to make this a little bit smaller to fit everything. Okay, to estimate the actual length, when he first approximated each distance to the nearest hundredth, she averaged the 4 numbers using a calculator to find her estimate. Well, using a calculator, and I don't happen to have one on me, but this is what we got. So if you use a calculator, you would have the square root of 60 would be about 7.75. And then 58 divided by 8, 7.25. 7.3 repeating. Okay, that's pretty easy. That's 7.3333. So you just need 2 threes there. And then 7 and 3/5 is 7.60. So the average, if you add this plus this plus this plus this and divide it by 4, you would get this. Winnie's father estimated the distance across this ranch was square root of 56. That's so weird. I'm not gonna. I think the distance across is the square root of 56. That's a weird way to express that. How does this distance compare with Wendy's estimate? The square root of 56. That's in between 7 and 8. It sounds like they would be pretty close together. Nearly identical. Yeah. Because the square root of 56 in a calculator is 7.483, 7.48, and that would round to 3. So that's very close. A real number in between square root. So we need to give an example of each type of number. A real number between square root of 13 and square root of 14. Geez, there's all kinds of. You just need a decimal in between those two. So you could take the square root of 13 and the square root of 14 and then pick a decimal in between. We can have this. Okay, 3.7. That's a real number because a real number, remember, it could be like a decimal or a fraction, or I mean, just about anything you could think of. An irrational number in between 5 and 7. I would say the square root of 6. I know that square roots are easy targets for irrational numbers. The square root of 6, yeah, I don't know what the square root of 6 is. So there you go. Or I think 2 times pi also is 6.28 about, and that's in between 5 and 7. So let's see what the publisher had to say. Square root of 31, whatever. Oh, I just messed up. I realized, yeah, the square root of 6 is not in between 5 and 7. Uh, yeah, that 5, oops, 5 squared is 25 and 7 squared is 49, and so I would pick like the square root of 26 or the square root of 27 or the square root of 28 or the square root of 29, right? Or the square root of 30, or they chose the square root of 31. But I would not pick the square root of 36, right? Because that is rational. These are all irrational square roots. So there you go. And we'll switch to the other side. Here, a teacher asks his students to write the numbers shown in order from least to greatest. Paul thinks the numbers are already in order. Sandra thinks they should be reversed. Who is right? The square root of 115. Let's see. That's like 10 squared is 100, and 11 squared is 121. And that's, I don't know, that looks like it's like 10.6. And 115 divided by 11. 11 times 11 is 121. Boy, that looks like it would probably be close to 10.6 also. Geez, these are all very close together. Well, if that's from least to great, yeah, they should. I think Sandra's right, because just with this alone, I think that's 10.6. No calculate, and then that's 10.5. So maybe they're reversed. Let's see. The answer should be. See, I wasn't quite sure about that. So if you have just put this in a calculator. 115 divided by 11 and the square root of 115, and that would be the order from least to greatest. 21. There's a famous irrational number called Euler's number, symbolized like this. It has an E, and like pi, the decimal form never ends or repeats. The first few digits of E are 2.71828, 18284. Between which two square roots of integers could you find this number? In between the square root of 4 and the square root of 9. Yeah, I would say so. Let's see what they say here. Even closer. I mean, I said 2 and 9. And they tighten it up a little bit. Okay. And between which two square roots of integers can you find pi? Let's see. Well, I mean, to be as precise as possible, you can do square root of 9, square root of 10. And let's see, there are several approximations used for pi, including 3.14 and 22 over 7. Pi is approximately 3.1415926535897933, and so on. So label pi and the two approximations on the number line. Okay, so here is our number line. Pi would be, obviously, as you can see, right about there, and 3.14 is less than that because it's missing all those other numbers in the decimal. 22 over 7 ends up being more than that. So there you go. Which of the two approximations is a better estimate for pi? So we're looking at the distance here. Jeez. Boy, they look about the same. Maybe the 22 over 7? Yeah, it's closer on the number line. That distance right here is closer than that, just slightly. Find a whole number, x, so that the ratio of x over 113 is a better estimate for pi, and give the two approximations. A whole number. So I would say 113 times 3.14 perhaps. That would be 355. All right. And in a set of 6 numbers that include both rational and irrational numbers is graphed on a number line, what is the fewest number of distinct points that need to be graphed, and explain? This is what the publisher has to say. You need 2. Irrational numbers can have the same location, and irrational numbers can have the same location, but they cannot share a location. And what I believe is happening here is we would have, you would have a number line, and you have, let's say, 0, and you have some kind of, this is a symbol for a rational number. And irrational, oh boy, I forgot what irrational symbol is. So I'm going to call it an I. Oh, man. Where's it Q? Anyway, so you have some, and if you put all of your rational numbers on one point, you can't have your irrational numbers stay on. So all your rational numbers can be on one point, and your irrational numbers can be on another point altogether. But they can't. The rational and the irrational can't be on the same point, and that hopefully makes sense because an irrational number is a decimal that never ends, but a rational number can end or has a repeated pattern. And so your irrational number could be right next to it. I'll call it an irrational number, but it can't actually be on that same dot. Jill says that, oh, yeah. Jill says that 12.6 repeating is less than 12.63. What's the error? Well, it's actually more because 12.6 repeating is 12.6666 and so on. It just keeps on going. And 12.63 right here, we can see that 12.6 repeating is bigger. So we have this. Should not consider the repeating digit 12.6666666. All right, so those are the ideas behind the independent practice. Lesson 14.3 of comparing rational numbers. I hope this has been helpful. Thanks for watching.